So how's everyone's day today? Okay. You guys want to do something fun then?
Wait, what?
You want to do something fun?
Like what?
Ooh, like maybe the riddle that you want. Sound
What
good?
riddle?
Okay. So seems like everyone's here, so let's get started. So move on. So today is going to be a review day, so it should be pretty easy. It's just to help us strengthen our knowledge of exponents. And since last guys, you guys struggled a little bit, I want to take this day to really like get to understand and know how to use these different operations. Cool. Yes, there will be a quiz, but it's going to be on this subject. And we learned this last class as well. So even if you weren't here last class, if you listen in to this class, it should be okay. You should be okay. So again, announcements. Today will be a review day, so we can better understand exponents and the different rules that we use to, a final test. No, probably not. There won't be a final test. We'll give you homework, but probably not a final test. This is not the last day, no. This is like 5th week, so you guys have like 3 more weeks after this week. Okay, yep, no problem. And again, today there'll be also some challenge problems at the end. So once you guys are more prepared to take these challenge problems, you guys can discuss and you guys can hopefully come up with some answers. Probably will be better than last class. Cool. Then today, again, there'll be a quiz after this topic at the end of class. Okay, anyone has any questions? Then like final exam, review stuff. I mean, anything. You can ask me anything right now. No? Okay. Well, let me move on. So again, let's go back to the video since I think this is really useful in trying to visualize and explain how these exponent rules work. And today we'll be reviewing and trying just to memorize these exponents. Yeah. Let's share sound. Okay.
All right, 3 laws down, 5 more to go. And these next 5 show us how we can do various math operations involving exponents. In fact, the next law tells us how we can take a number raised to a power and then raise that to a power. As you can see, it shows an expression, x to the power of m, grouped inside parentheses, and then that whole group is being raised to the nth power. It's a nesting situation, kind of like those Russian nest.
Oh, Edward, do you have a question?
Oops, sorry.
Oh, okay.
Nesting dolls. So what if someone asks you to simplify the expression x squared cubed, which means the entire x squared term is raised to the 3rd power? Well, our law tells us that we can simplify that by multiplying the exponents together. See how it equals x to the power of mn, which means m times n? That means x squared raised to the 3rd power would be the same as x to the power of 2 times 3, which is 6. Want to see why that's true? Well, think about what it would mean to raise x squared to the 3rd power. It would mean multiplying 3 x squared terms together, like this. And each one of those x squared terms simplifies to x times x, right? So we end up with 6 x's being multiplied together, which is just x to the 6th power. See, our law works great. If you have a number raised to a power, and that's all raised to another power, you can just multiply the 2 exponents together to simplify it. And it works for negative exponents too. Like what if we had x squared raised to the negative 3rd power? Well, our law tells us that that's the same as x to the power of 2 times negative 3, which is x to the negative 6th. To see if that's true, we'll need to use the law we just learned about negative exponents and rewrite this as 1 over x squared to the positive third power. That simplifies to 1 over x squared times x squared times x squared, which in turn simplifies to 1 over 6x's being multiplied together. And that all checks out because 1 over x to the 6th would be the same as x to the negative 6th power. Pretty cool, huh? Okay, we're halfway through our list of laws, and we're going to look at the next two as a set because they tell us how we can multiply and divide expressions that have the same base. And that's important because we couldn't simplify them to have a single exponent if the bases were different. The first law says that if we have the base x with exponent m being multiplied by the same base x with exponent n, we can combine them simply by adding the exponents together. And the second law says if we have the base x with exponent m being divided by the same base x with exponent n, we can combine them simply by subtracting the exponents. Let's see some examples of each, like this one, 2 to the third times 2 to the fourth. Does that fit the pattern of our first law? Yep, the base of both expressions is the same, but they happen to have different exponents. The law would still work if the exponents were the same, but they don't have to be. Just the bases have to be the same. Our law tells us that this would equal 2 to the power of 3 plus 4, or 2 to the 7th power. But does it? Well, let's break it down and see. 2 to the third is 2 times 2 times 2, and that's being multiplied by 2 to the fourth, which is 2 times 2 times 2 times 2. That's a lot of 2's being multiplied together, 7 2's to be exact. Aha! So that is what you'd get by just adding the exponents together, since 3 plus 4 equals 7. And this law makes total sense if you think about what an exponent really means. The exponent is telling you to do repeated multiplication of the base, right? So this first part is telling you to multiply 3 2's together, and the second part is telling you to multiply 4 2's together. So that's why you can add the exponents together if the base is the same. Or think about it like this. If we had 10 x's all being multiplied together, we could form different groups of them and combine them using exponents. Like we could combine the first 4 x's into x to the fourth, and combine the remaining 6 x's into x to the 6th. And of course, those expressions would be multiplied together since all of the x's were being multiplied. But you'd probably never want to do that, would you? I mean, why not just combine all 10 x's into the expression x to the 10th? Ah, but there you see that our law holds true. X to the fourth times x to the 6th would equal x to the power of 4 plus 6, or x to the 10th. Okay, now let's...
Okay, does anyone have any questions? So this should be pretty easy. This is just review. So we'll get just started to do some practice problems and just trying to, yeah, okay. Yep. We're just going to do some practice problems and just getting more and more practice so you guys can get these exponential rules down. So again, reminder from last class, multiplying exponents with the same base leads you to adding the exponents together. On the other hand, dividing exponents lead to subtraction. And then if you have an exponent of an exponent, you multiply the exponents together. So basically, if there's like, say, 2 to the exponent of 4, and then you have another exponent of 3, you instead multiply the 4 and the 3 together, and you get 2 to the exponent of 12, which is a very large number. Okay? And then for the last one, a fractional exponent, like okay, yeah, okay, sure. So a fractional exponent, like 1/2, you would use a square root, basically doing the opposite of what we do with the power. So like if you do like 2 to the power 2, it's 4. But if you do 1/2, you do the opposite of 2. And the opposite of the power 2 would be going back to 2, basically. And the same thing with 3. So 3 to the power 2 equals 9. And then you have a 1/2 exponent, you go back to 3. So you kind of see how the fractional exponents just reverse what you just did with exponents, if that makes sense. Cool? Okay. Let's move on and let's do some practice with just addition. So here you go. There's some 3 questions, and you guys can get started. And again, if there's a negative sign, you just add them all together. If it's negative, you subtract. If it's positive, you add together. Oh, once again, you guys can write this in exponential form. You don't have to write it out completely because I know some of these are a little difficult to write out completely. So just leave them in exponential forms, or if you want, you can leave it in fractions as well. Okay, are you guys done? Again, you can leave these in just exponential form. Okay. Seems like one person needs some more time.
I need more time.
Okay, sure. Okay, so you guys finished the 3 questions. Let's go over the first question. Let's do waterfall again. Okay, so I want you guys to post the answer of question 1 on my count of 3. So when I count down to 3, 2, 1, and then you guys all press enter at the same time. Cool? Okay. Okay, you're a bit early, Lori, but yes. 3. Oh, you have a question, Edward?
No.
No? Okay. So put your answer for question 1 and press enter in 3, 2, 1, go. Okay. Cool, okay. I see some different answers. Cool. Okay. So let's go over this again. Again, most of you guys got this, and you know that you can leave the answer in exponential form as well. So let us look at question 1. So we have 3 to the power 2 multiplied by 3 to the negative 1 multiplied by 3 to the power of 3. So by the rule of exponential addition, we can basically take the 2, the negative 1, and the 3 and combine them together basically. So once we combine them together, we get 3 to the power of 4. And in this case, this would be our answer. So most of you guys got that. And again, I don't expect you guys to simplify this because on some of these, it's going to leave a really big exponent. And most of the time, your teachers would just accept these exponents right here because they're the right answer anyway. You don't have to simplify them. Okay, cool. Now let's do question 2. So load the answer in chat and press enter in 3, 2, 1, go. Okay, good. Okay. Yeah. See, everyone got this. That's nice. So again, we combine these together and it's just very simple subtraction and addition. Add 2, add 1, we just get 2 to the power of -2. And again, since it's negative, all we do is just flip it. And then if we simplify it, it just becomes 1/4. Cool, okay. So now let's do question 3. Load the answers in chat for question 3 and press enter in 3, 2, 1, go. Okay, does anyone else have any answers? I want to see Loya's answer right now. Is it right though? It's no one else is posting answers. Yep, post answer. Okay, oh, okay. See, a few more people post it. Okay. Well, most of you guys got this correct. So for the last one, again, just simple addition. We have 2 minus 5 minus 3. And again, this leads to 5 to the -6. Because we have -8 plus 2, which is -6. So again, this is just a very simple addition and subtraction. And then this allows you to solve these exponential equations very quickly without having to basically figure out what this is or what this is. Cool? Okay. I don't think anyone has any questions, so let's move on to subtraction. So instead of multiplying them, the exponents, we are now dividing them, and this leads to subtracting the exponents. So again, there are 3 questions. You guys can work on them, and this time I threw in some questions about converting exponents, and I want to see if you guys can get them. Cool? Okay. Actually, for now, I want you guys to save your answers. You don't have to send it to me right now because I want all you guys to answer at the same time. And it doesn't matter if you're right or wrong. I just want to see what you guys think the right answer is. Okay? Sound good? Okay. Okay, is everyone done? You can type in yes or no. If you need more time, you can always type no. Not yet, cool. Okay, I'll give you guys some more time then. Okay, seems like some people are done. Does anyone else need more time? No? Okay. So load the answers into chat for question 1. Oh, Youngki, do you need more time or are you done? Okay, you're good. Cool. So again, load your answers for question 1 in chat and press enter in 3, 2, 1, go. Okay, okay. Anyone else? Again, you can leave these in exponential form. I'm fine with that as well. Anyone else? I want to see 3 answers. Okay. I want all you guys to participate. Is that fine? Like, can everyone type in the answer? I just want to see if you guys could, see if you pay attention to me, okay? So I want everyone to send me an answer. Cool.
Also, how do you send an exponent forms instead of different numbers?
Okay. There is a key on keyboard. It's the number 6 key. If you shift and press 6, it will give you the caret sign. And that caret sign means an exponent, basically. So let me type this in chat. Say if I was to write the first equation out.
No, I know that part. I'm just saying because there are different numbers.
They're different bases, right?
Yeah.
Okay. Oh, were you here in the class about converting exponents?
Probably not.
No, okay. Well, here, let me go over the first question then, very quickly. So basically, for converting exponents, all we do is we think about, okay, so this is a 9, and what perfect square is a 9, basically?
3.
3. So it's 3 squared, basically, right? So instead of a 9, we can substitute this 9, and we can put in 3 to the power 2. So now we have 3x squared with 3 to negative 1 divided by 3 over 3. So do you remember in the video what they talked about when you have an exponent of an exponent? Do you remember? Yes? Yeah. So all you do is you just multiply them together. And basically what you get is, negative 2 from that. And then also have divided by 3 to the power 3. So again, when we multiply these together, I know that 2 minus 2 equals 0, so I can cross these out. And in the end, you just get 1 over 3 to the power 3. So that's the first question's answer. Cool? You got that, Andrew? Does that make sense? Cool. Okay. So let's do this then. Everyone load in the answer for question 2 in chat and press enter in 3, 2, 1, go. Okay. What's your answer for question 2, Ian? Hello? Can you hear me? Okay, well, does anyone else have any answers for question 2? Again, I want all you guys to participate. Is that fine? I want like most of you guys to put in an answer. Okay. Yep, no, Bowen and Young Ki are fine. I want everyone else to put in an answer. So Edward, could you put in the answer as well? Okay, so I guess no one else wants to put an answer. I mean, that's fine. Oh well. Okay, so we have two different answers. We have 4 to the power 0 or 1. You guys can simplify that pretty easily, or 1 divided by 32. So I wonder what's the right answer for the second question. Okay, so once again, we see that, oh, look, the bases are not the same. But I know that 4 is a perfect square of 2. So I can substitute that 4, and that can become a 2 instead, 2 to the power 2. So now my equation looks like 2 to the negative 5 times 2 to the power 4 divided by 2 to the power 2 to the exponent of 2. So now, once again, through the power of exponential multiplication, I know that this is now 4. And then now we have 2 to the negative 5 times 2 to the power 4 divided by 2 to the power 4. And then I know that the same base divided by the same thing is just 1. So 2 to the power 4 divided by 2 to the power 4 is the same thing. So I can cross those out. And in the end, I just get 2 to the negative 5 or 1 to the, basically I can take this exponent and flip it. And I'll get 2 to the power 5 over 1. Sorry, 1 over 2 to the power 5. And in the end, I get 1 over 32. Cool? Does that make sense, Andrew? Okay, cool. Now let's do the last question, okay? I want everyone to participate, okay? So load the answer for question 3 in chat and press enter in 3, 2, 1, go. Okay, okay. 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 Ooh, that's some different answers. Okay, I'm just curious. Youngki, is it okay if you explain the last question? It's fine if you can't. You can just tell me. Okay. Well, let's see. We have two different answers. So we have basically 1 over 3 to the power 7, basically, and we have 5 to the power 6. Well, let me think about this first of all. So I look at it and I see that there's a base of 3. So once again, I can convert that 9 into 3 squared. I can substitute that back in, and now I get 3 squared times 3 to the negative 5 divided by 3 to 4, basically. Now let's add and subtract them together. So I know that I first add the 2 with the negative 5, and then I subtracted negative 4 because it's being divided. So now, after I resolve all these exponents due to all the addition and subtraction rules, what I get is basically 2 minus 9 or 3 to the negative 7. So yeah, so does that make sense?
Yeah.
Cool, okay. Let me clear this and let's move on. Now let's do multiplication. Now these should be very simple. It shouldn't take too long, okay?
We solve these?
Oh, do you want me to solve these?
No, I mean, do we solve them? Like, or just exponent form?
You just multiply the exponents together.
Oh, okay.
Yeah, so it's very simple. You just multiply the exponents together. Yep, Bowen's already done. Yep, it shouldn't be that hard. And again, you can leave it in exponential form. But since I was nice, I made these exponents not too hard. Okay. Yep, okay. Most of you guys got that. So load your answer for question 1 in chat and press enter in 3, 2, 1, go. Yep. Okay. Yeah. Yep. Okay. Yeah. Everyone got question 2, right? Yep. All you do is just multiply the two things together. So this is just 3 to the power 2, just 9. Okay. Now let's load the answer for question 2 in chat and press enter in 3, 2, 1, go. Okay. Ooh. Yep. Okay. Okay. So everyone got it correct, but we'll just make sure that you remember the base, okay? So it's 2 this time. Make sure you don't write the wrong base. So again, this is very simple. It's just 2 to the negative 4. Then what about the last question? No problem. Press enter in 3, 2, 1, go. Yep. Okay. Yep. Just 2 to the 8. I don't think I need to explain that. Okay. I think everyone seems good with that. Cool. Now let's do division. This is just, sorry, well, fractions. Fractions are as close as we could get to divisions for exponents. So again, this shouldn't take too long. I made these pretty easy. Okay, no worries. I'll go over them once everyone is done. Don't worry about that. Okay, is everyone done? You can type in yes or no. I know that one person's done. Okay, I think everyone's done. So let's go on to the first question. So again, with 1/2, we think about the power of 2. So say we do 2 to the power of 2. This is 4, right? Now, if we do the opposite, what's 4 to the negative 1/2? Does anyone know? 2. Yeah, Andrew, yeah, 2. So basically, we just take the opposite of what a power would do. So in this case, we have a 9. So an opposite of, say, a square for 9, a square root of 9 would be what? Yeah, it would just be 3 because basically a negative 1/2 just means square root 9. That'll be just 3. Okay, now let's learn the answer for question 2 in chat and press enter in 3, 2, 1, go. Okay. We have 3. Anyone else? Three. Okay. Well, thank you, Andrew and Bowen, for answering. Well, sorry, question 2. Load in the answer for question 2 in chat and you press enter now. Got 3, okay. Anyone else? 3, okay. Anyone else? Does anyone else have a different answer? You can type it in everyone's chat so you guys can compare. I mean, I know Ian, you sent me your answer, right?
Yeah.
Okay, okay. So let's see, the main consensus is 3. And Ian instead says 1/3. So let's see which of you guys are right. So once again, we have an exponent of exponent. So what do we do with the exponent of exponent? We basically just multiply them together. So in this case, we have -5 multiplied by 1/5. And since we multiply these fractions together, if you remember in like, I believe 4th grade or 3rd grade, when you multiply these fractions together, you can just move the numerator, just multiply the numerator, and you can move these over and get 5/5. Now we can simplify this to just 1. So end result is that we get 3 to the -1. So when we have a 3 to the -1, we take the 3 and we put it in the denominator. Basically flip it. And now we get 1/3. Does that make sense? Yes, 1/3. Come on, Lori, you got answer it when everyone else answers, okay? Yeah, okay. Okay. So now let's do the third question. Load your answers for the third question in chat and press enter in 3, 2, 1, go. Okay. Okay, Andrew says 2. Okay. Ian is very confident in the answer of 2. Okay, anyone else? Yes, very confident in the answer of 2, to the point that he is saying 2 many times over. Okay. So, yeah, most of you got that correct, which is really good. So basically, we thought about, okay, so what is the opposite of a cube? So say if you have a 2 to the power 3, we get 8. And now, if we take the opposite of that, basically 8, basically cube rooted, we get instead 2. So basically we just reverse the operations. And yeah, it's very simple like that. Cool. Okay, does anyone have any questions? Yep. Now we'll be going over to challenge questions. So if anyone has any questions before those, please ask them now. And then if not, we'll go straight to the challenge problems and I'll break you guys up into breakout rooms and you guys can discuss and see what answers you think are correct. Cool? Okay. Yes, there is challenge problems. Oh, okay. Can you guys not do that? Oh, you know what? Let's skip this. We don't need that. I think you guys are good enough. Let's go to the
Really
first
hard.
challenge problem. So let me open up breakout rooms and let me see. Okay,
I already know the answer.
okay.
I already know the answer.
Now, okay, rooms are open, so you guys can join the rooms. Make sure to jot down the question and so make sure that have one of you guys at least jot down the answers and yeah, good luck. Can you guys join your breakout rooms? Is that working for you? Or no? Joanne or David? Okay, cool. How about you, Joanne? Is there any problems? Okay.
Recording in progress.
We also finished with problem 2.
Yep. Okay, let's move back. Okay, so again, this is the question, and now everyone's back. Let's compare answers. So group 1, what was your answer for challenge problem 1? Okay, cool. 1. You can save the answer for challenge question 2. And you can just type it to me because I think we're just going to skip that one for today. Okay. Group 2. Group 2. Can you guys put in your answer in chat? So group 1 got 1. How about you guys?
Hello, I'm back.
It was like Edward and Alan and things like that. People,
Yes.
you guys can type in chat or you guys can talk out loud.
But- so, what are we supposed to do?
Just type in the answer in chat, like in everyone chat. Like, what do you guys get for the answer?
I think I actually sort of think it's 1.
Oh, it's 1. Okay. Well, 2 people think it's 1. Well, 2
I
groups.
think
How
it's
about
1.
the third
I
group?
think it's 1.
What do you guys think is 1? You guys think it's 1 or you guys think it's something else? Third group. Okay. Oh, let's solve this. Everyone thinks it's 1. Ooh, this is good. We reach a consensus. Nice. So once again, instead of having to expand these exponents, yes, I know everyone is very confident in answer 1. We can convert these exponents into things I know. So you know that 64 is 2 to the power of 6 and 8 is 2 to the power of 3, right? So now I can use those conversions and write it out like this. So now it's very simple actually. Now I just do multiplication on the exponents. And now I see that it's 2 to the power of 12 divided by 2 to the power of 12. And now this is just 1. So yeah, everyone got that correct. Nice.
I have another solution.
Okay, Andrew.
Or is it just you just do since 64?
Oh yeah. You can also do that. Since you're doing another method, which is also cool. You saw that there was a 4 here, and you saw that it was 64. So either you can first change this to 8, or you can change this 8 into 64. So say if you change this 8 into 64, you have to basically do 8 to the power 2 to the power 2, and then afterwards you can do this. And it's the same thing. So that you will also get 1. Cool. Okay, so everyone got that. Nice. So let's skip challenge question 2 and let's do the last one. Okay, and once again, I'll give you guys breakout rooms. And yeah, good luck. Okay, and then
go back.
Recording in progress.
What now?
Yeah, Kyle, what now?
Why is everybody muted? When are we going to continue class?
I think we're supposed to end class now. It's 7:30 exact. Well, it's 30. Depending where you are.
Can we go now?
Mine is 7.
Is it time to leave? Kyle,
Yes.
you're muted.
You're muted.
Sorry. Yes, I was talking. So can group one give me the answers?
It's 11:30 p.m. That's like so late.
Yeah, that's kind of late.
For me, it's 7:30.
Okay. So can group one give me the answers, and then once you guys are done, I'll give you guys the quiz, and you can finish the quiz either today or you can finish it before the next class. Cool. Oh, it's 11 in the morning. Yeah, that's fine. That's fine. Oh, you're in Pacific time. Okay. Okay, group one. Can you guys send me the answers? Okay, group one says 3 to the power of 21. Okay, group two, what's your answer? And it's okay if you don't have an answer. You can just say it, not finished, since I kind of wish you guys, sorry. Okay, group three says 1 divided by 27. Okay, so now let me go back to this. Oh, let me go back and let me quickly explain it. Share screen. There you go. Now let's quickly do this one. Let's see how fast I can finish this one. Okay, so 27. 27 is 3 to the power of 3, correct? Now it's this. Now 9. 9 is 3 to the power of 2. Now we have a 3 again. Now we have -2. So now this is 6. This is 12. 3 to the -12. So now we have 3 to the power of 9 divided by 3 to the -12. We know that since it's 3 to the -9 divided by 3 to the -12, flipping this negative exponent means I bring it up. So now the final answer would be 3, 9 plus 12, or 3 to the 21. So let's see who got it right. Ooh, so yeah, that was fast. So group one got it right. Nice. Okay. So does that make sense? So you see, like, even with this question, I can go super fast because I know these exponential rules to heart. So once you guys like really practice with these exponential rules, you can do them super quickly. And again, you guys can check this before the calculator, like here. Oh. Let me type this out. So, okay, yeah, it's too big of a number, never mind. Okay, so, oh, we're done, guys. So here's the quiz. You guys can save this link again. I'll tell Eric to send out email with this link. Yes, I would try it. Yes, you would definitely should try it. But in order to really check if it's right, you have to check using a calculator or have someone else check it.
Bye. Thank
Yeah.
you.
No
See you
problem.
next time.
Mm.
Bye. Bye. Bye.
Bowen, you can do that now. Did you guys like this better? Is that yes or no?
All right.
Edward, do you like this better or no?
What?
Was this class better than last class?
It's pretty good.
Okay, cool. Okay.
Okay. Bye.
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 Ian, do you have any questions? Again, you guys can leave. You don't have to stay for the quiz.
I'm just doing the quiz.
Okay, okay. I expect you to be finished in less than 2 minutes. It should not be too hard. Also, you're a great student, Ian. Okay, well, I'll be closing class, and I guess I'll see you guys later.